Hello and welcome to another Mad Mongoose math video where you get to play the therapist and solve maths problems. Today we're going to be covering lesson 1.4, rewriting equations and formulas. This is on page 26 in your blue Big Ideas math book, so turn there and we'll get started. We have one vocabulary term in this lesson, and that is a literal equation. A literal equation is an equation with two or more variables. Up until this point in lessons 1.1, 1.2, and 1.3, we've only had one variable, but here we will have two. An example of a literal equation looks like this, where we could have 2y plus 5x equals 6. That is a literal equation simply because it has one variable, two variables, in this case an x and a y. Our task today will be solving these literal equations for a variable. Here is that example that we used, 2y plus 5x equals 6. This is example number 1 in your book on page 26. And the directions tell us to solve for y. It could easily say solve for x, but in this particular example it says solve for y. So what it's asking us to do is to isolate y on its own side of the equal sign and move everything else to the opposite side. So to do that, I'm going to get rid of my addition or subtraction first by using the inverse operation, and that's going to be subtracting 5x. Since my whole goal is to isolate y, I need to move everything else away from y. It wants to be a loner. Okay, I'm going to subtract 5x from both sides. Keep in mind that when you do this, you cannot combine terms that are not the same. So 6 doesn't have an x, so you can't do 6 minus 5x. Over on this side, 5x minus 5x is equal to 0, so that leaves me with 2y on this side. And then we have 6 minus 5x. We don't actually perform that operation because, like I said, we can't combine terms that are not alike. So from here I need to continue the process and I need to isolate y by itself. To do so, I see that 2 is being multiplied by y, so the inverse operation of that is going to divide by 2. Like that. And now the 2's cancel out on this side, leaving us with y. 6 divided by 2 is 3. 5 can't be divided by 2, so we leave that as negative 5 over 2x. And that's going to be our solution. Once you have the y isolated, like you do here, you're done. You've solved for y. So our answer is y equals 3 minus 5 over 2x. Okay, this one is the on your own example number 1. You'll notice that the y is red, and what they're trying to tell you is that they want you to solve for that variable. So just like in the last one, they want you to solve for y. So isolate y, pause the video, see what you get, unpause it, and we'll work it through together. Alright, since we want to isolate y, we need to move x to the other side, and since it's a negative x, we're going to do the inverse operation and add x. Okay, you can't combine 10 and x because 10 doesn't have an x, so you just do 10 plus x over here. Negative x plus x cancels out, and you're left with 5y on this side. Now we need to get rid of the 5 by doing the inverse operation, which is dividing by 5. So we divide each term over here by 5. That gives us y. 10 divided by 5 is 2. And then we have x over 5. Alright, here's another one. This one is number 3 of the On Your Own on page 26. Once again, you're solving for y. So pause it and see what you can come up with. Alright, since you're solving for y, you need to get rid of the 6x. So to do that, we're going to subtract 6x since it's positive. That leaves us with just 3y on this side. And since we've got to subtract 6x, that's going to be 12 minus 6x over here. And then we have to divide by 3 to undo the multiplication. So that cancels it out over here. We're left with y. And then we'll have 12 divided by 3 is 4, the negative. And then we got 6 divided by 3 is 2x. So your answer, I'm going to rewrite it in the correct form. Y equals 4 minus 2x should be your correct answer. Alright, here we're going to be working with a formula, and as you can see, I've underlined, this is example number 2, and they want you to solve for L. This formula is actually the way to find the surface area for a cone, which you find by multiplying pi r squared and adding it to pi times the radius times the length. So we're going to solve this for L in the same way that we do all the other formulas, and what we're going to do first is we're going to take this chunk, pi r squared, and we're going to just subtract that whole term. Subtract pi r squared, and we're going to subtract it from the other side as well, and that's going to leave us with s minus pi r squared. This cancels out, and on the other side, we're just left with pi r times L. Okay, from here, now all you had to do is we're still trying to isolate that L, remember, but notice it's being multiplied by R and by pi. So to get rid of that, we just need to divide. Use the inverse multiplication, divide by pi and the R from this side, and divide by pi and R on this side. This side cancels out, and you'll notice that L is all by itself on this side. So L is going to be equal to s minus pi r squared, all divided by pi times r. Okay, I know it's going to take a little bit of practice to use some of these formulas when you're solving for variables. So let's try another one. Let's try number 5. Okay, number 5 of the on your own on page 26 is I equals P times R times T, and that formula is for simple interest, and they want us to solve for P. So why don't you try this one? You're trying to solve for P, pause the video, and when you think you got it, unpause it and we'll work it out. All right, so from here, we got to solve for P, and we notice that P is being multiplied to R and T. So to get rid of R and T, since it's all multiplication, we're going to divide each side by R times T. Divide this side by R times T. On this side, it cancels out, and we have P already. So I'm just going to put that variable on this side. P equals I divided by RT, and you're done. Okay, here's another formula, and in this formula, this is C equals 5 over 9 times the whole quantity of F minus 32. And what this formula is C stands for degrees in Celsius, F stands for degrees in Fahrenheit, and you'll use this formula to convert from either from Fahrenheit to Celsius or from Celsius to Fahrenheit. So you'll notice example number 3. Okay, so here, this is example number 3, and in this example, they're going to want us to solve for F, okay? So isolate F. And the first thing that we need to do is we need to get rid of this 5/9 that's being multiplied
to the whole quantity f minus 32. So we need to get rid of that. And since this 5/9 is being multiplied to the f minus 32, we need to do the inverse operation of multiplication, which in this case is division. Okay, so if we're going to do 5/9 divided by 5/9, that's going to look really messy. So remember this rule: whenever you're multiplying by, whenever you're dividing by a fraction, the rule is that you have to flip the fraction upside down. So this one's going to become 9/5, and then you multiply. Okay, what that does is it cross cancels both of your numerators and your denominators, leaving you with 1. So we don't have to write that 1, so we're just left with f minus 32 on the right side of the equal sign. And on the left side, remember, we still have that c, but you need to multiply that by the 9/5 still. Okay? Once we do that, we have one more step to isolate the f, and it's f minus 32. And so to isolate f one step further, remember the opposite of subtraction would be addition. So we're going to plus 32 to both sides. And you'll see now that we have f isolated by itself, and I'm just going to rewrite it so that way f is on the left side. F equals c times 9/5 plus 32. And that would be our answer because we've solved for f. Okay, so now let's use this formula we just found in the last example to solve a problem. A problem that you might have might say something like this. How many degrees Fahrenheit is 16 degrees Celsius? And now to find this out, you already have F, and F stands for Fahrenheit, so that stays there. And the problem would want to know how many degrees Fahrenheit is 16 degrees Celsius. Well, we know that Celsius is 16, so we plug that into a formula. We know that we have to multiply that by 9/5, and then whatever that answer is, we have to add 32 degrees to that. Okay, so 16 times 9/5, do that first. You do that, you're going to get 28.8, and then you got to add 32 to that, and whatever that equals is going to be how many degrees Fahrenheit? 16 degrees Celsius. Our last step then is just to add 28.8 plus 32, and that would give us a final answer of 60.8. Okay, so 16 degrees Celsius is equal to 60.8 degrees Fahrenheit, right? All right, I hope that made sense. I guess we'll close with the joke of the day. How many tickles does it take to make an octopus laugh? The answer? 10 tickles. All right, guys, I hope you learned something, and we will see you next time.